In this video, we're going to cover example 4 from topic 5.6, concavity. We are going to look at, and this one I believe is missing some information. I think it should have had what I had the typo on the last one. It should have had the interval from 0 to 2 pi on it. So find open intervals. Notice it says they're open. Yay. Where g of x is concave up or concave down, and find any points of inflection. Give a reason for your answer. And as always, we want to look where we're starting. We are starting with the first derivative. To get to concavity, we need to go to the second derivative. So we're going to go g double prime. Now, I'm not going to do g double prime yet. Look at what's going on here. I'm going to rewrite g prime actually. So g prime of x equals sine of x squared plus cosine x. I have a chain rule with trig. Isn't that exciting? So u equals sine x, which means that u prime equals cosine x. I'm going to call it y equals, so I'm going to replace the sine with u, so u squared. So y prime would be 2u times the cosine of x. And then when I actually write that out, so g double prime of x equals 2, I'm going to replace the u with sine x, cosine x, and then we still have to take the derivative of this piece, which would be negative sine x. Now I set that equal to 0. If you notice, this group and this group have a greatest common factor of sine, so I'm going to pull that out. So we've got sine of x times 2 cosine of x minus 1 equals 0. I'm going to set both of those equal to 0 by the zero product property. And we're going to I'm going to solve this one here. So 2 cosine x equals 1. So cosine x equals 1/2. We're going to break out our unit circles. So I need to find the radian measures where this is happening. So sine of 0, we're looking for where the y values in my coordinates are 0. So I know that happens at 0, which is it's out 1, up 0. So I know that happens at 0. I know that also happens at pi, and hey, since we can go all the way to 2 pi, it also happens at 2 pi. So I've got 0, pi, and 2 pi. Now I'm looking for where the x value, remember the cosine is the x value, is equal to positive 1/2. So I'm going to write this coordinate here is out 0, up 1. So I know I count down from that coordinate, so there's my 1/2 right there. So that's at 2 pi over 3. I know I'm going to count down this way as well. So it's going to be 1/2 right there. Ooh, but that's positive. Let's see. This would be negative. So that doesn't work, does it? This one's positive, so that's pi over 3. So I know I've got pi over 3 for sure. The other place where my cosine is positive is quadrant 4. So I'm out 0, up 1. So we are at this one right here. Let's see, this is 3 pi over 3, 4 pi over 3. This one would be 5 pi over 3 is the other place where it would be positive 1/2 in the x coordinate. So 5 pi over 3. I am going to use that to draw my sign chart now. I'm going to put my sign chart out to the right here. Let's see if you can get it squeezed in there. So I'm going to write my intervals just like I did with my increasing, decreasing. I'm going to start though at 0. And then I am going to go to my first fence is at pi over 3. My next fence would be at pi. Then my next fence would be at 5 pi over 3. And then my final fence would be my final value would be at 2 pi. And then I've got x, and I've got f double prime, and what's going on with f. So I got to pick a value between 0 and 3 pi over 3, which I would pick pi over 4 probably. Between pi over 3 and pi, I would pick pi over 2 because that's a quadrant angle. Between pi and 5 pi over 3, I would pick 3 pi over 2 because it's a quadrant angle. And between 5 pi over 3 and 2 pi, let's see, this would be 4 pi over 4, 5 pi over 4, 6 pi over 7 pi over 4 is what I would pick. 7 pi over 4. All right, so we need to plug those in to our most simplified form of the derivative, which is this right here, and figure out what's going on. And really all I need to know is what is the sign of the values there. So let's start with pi over 4. Okay, pi over 4, no matter what we do, we know both the sine and the cosine are positive numbers. So I know the sine would be positive. I know that this would be positive square root of 2 over 2. Sorry, I'm doing some little scratch work here. So square root of 2 over 2 is what cosine is there. So I know square root of 2 minus 1 is going to be something that's positive. So positive, positive is going to be positive. At pi over 2, luckily we have this. So I know that my sine is for sure positive. My cosine is 0, so this part becomes 0, so that's going to make this overall thing negative, because 0 minus 1 is negative. A positive times a negative would be negative. At 3 pi over 2, so I'm going to do that one in green, we're going to have the sine is the y-coordinate, so it is still positive. The cosine is 0 again, so that's going to make it, it's going to be overall negative again. All right, and then it's 7 pi over 4. Let's see, we haven't used this color yet. So it's 7 pi over 4. I know it's got to be square root of 2 over 2, negative square root of 2 over 2. So my sine is negative, whereas my cosine turns out to be positive, and it's going to be the same relationship here. So I know I've got a negative times a positive, so it is still negative. All right, I just realized I made a boo-boo, so I'm going to go back to the green one here. This should have been a negative 1 on here, which makes this negative. And then when this one was green, it was 0 minus 1, which was negative. So a negative times a negative would be positive. All right. Now that we've got that fixed, when we are positive, we are concave up like a cup. When we are negative, we are concave down like a frown. So we are going to now write that out, and then we notice anytime we alternate signs, we've got points of inflection. So F is concave up on 0 to pi over 3 and pi to 5 pi over 3, because F double prime, remember this row is the reason, F double prime is greater than 0 on these intervals. Okay. F is concave down on pi over 3 to pi and 5 pi over 3 to 2 pi. Again, we're looking at this row for reasoning because F double prime is less than 0 on these intervals. Then, that says intervals. I did not do a good job of writing it. Okay. Then we need to look at the sign. So every time a sign changes, we know we've got a point of inflection. So we had a sign change, a sign change, a sign change. So those are all points of inflection. So F has points of inflection at x equals pi over 3, pi, 5 pi over 3, because F double prime changes sign at these values.